Good afternoon. My name is Michael Rhodes, and I'm an instructor with the Educational Services Department in Charlotte, North Carolina. Joining me today is Bruce Harold, who is product manager with the desktop team in Redlands, California. We want to welcome all of you today to the slide training seminar. Today we're going to focus on using Python in ArcGIS Desktop 10, and we're going to focus on some of the new functions that you can add to Python can add to 10. So we'll be pointing that out as we go through the presentation. We're going to look at some basic benefits and advantages of Python, and then we're going to talk about the basic Python syntax. For those that may not have any experience with Python or don't have really a programming background, we're going to discuss some of the basic syntax that you will probably any script you write will contain. And I'm going to show you how you can use that then to automate the geoprocessing tools. For those that do have more experience, we're going to be talking more about the advanced functions and properties a little later in the seminar. So we'll be pointing out some of the advantages that we can gain from running Python scripts, some of the more advanced functions that you can perform. Each of these topics will be followed by a software demonstration, and then we'll turn it over to Bruce, who will answer your questions. Remember, you can send questions at any time during the presentation. Python is an open source, cross-platform, meaning we can run it on Windows or Unix or Linux. It's fairly easy to use. It's a scripting macro type language, and it's object-oriented, and it's freely available. It's open source. You can download it from numerous sites. The idea behind Python is to automate your workflows fairly easily. So that, for an example, you might take a Python script that will execute in the middle of the night through a scheduler. That script can then go and copy data or convert data in a batch mode. So you can take larger numbers of files and process those during your times when your system isn't busy. What we'll probably be most interested in today on this seminar is the ability to take Python scripts and automate the geoprocessing tools. So there's several hundred tools available to you in the Arc toolbox. We're going to be able to take those tools, put them into a script, and execute them in any order that you would like. And you're going to find that just some basic understanding of scripts, basic understanding of the tools in a toolbox, you'll be able to automate these things fairly easily. Besides automating just the tools in a toolbox, we also have the ability to work with some of the more advanced functions. In other words, we could, for instance, we could take a table and we can loop through that table. We can read and write to the table. So we can manipulate tabular data. You can also manipulate map documents and layers within the map document. This is new at version 10, new ability. We'll be talking more about this a little bit later. And we can also take geometry, points, lines, and polygons, and manipulate those. We'll see a couple of examples of how this works throughout the seminar. Where do we run Python code from? Well, there's a number of places you can type into code or execute it from. If you're serious about writing Python scripts, you'll probably want to use some kind of a Python editor. The one I'm showing on the screen is called Python Win. This is fairly common, but keep in mind there are many editors available to you. From some are free, some you can purchase. There's one called IDLE that's built into Python. If you want, you can use that one. I use this Python Win fairly often. The idea of the editor is it's going to give you the ability to type the code in, to enter it, to debug it, and also to execute it. And when you execute the code, you don't necessarily have to have arcmap or arccatalog open. They don't have to be running at the time in order to run the code from this editor. It can be run standalone on its own. You could also run the code from the new Python window. This is new at version 10, so in arcmap, there's a window called the Python window. This actually replaces the older command line window that was there in version 9. In this window, you can type in individual commands. You can type in Python code within it. Some of you might recognize it looks fairly similar to an interactive window that you have in many of the editors. We'll be showing some of this a little bit later. You can also take a Python script and add it to the toolbox as a tool. This has a lot of advantages to it. We'll see an example of this later in the demonstration. And finally, you can run Python code within the field calculator if you want. This is new at version 10, this ability. At this point, I'm going to go to ArcMap, and I'm going to show you an example of running an actual script. So to do this, I'm going to open up the Python window we just discussed, And I'm going to right-click and load an existing script into this Python window. So I have a script that will buffer some roads for me. And we're going to talk more details about the code in just a little bit. So we won't worry about the actual syntax at this point. We're just simply going to run the code. As this is running, it's going to run in the background. This is a new feature in version 10 that we can run any of the tools in the toolbox, or scripts in this case, can be run in the background. And as they're running, you can continue to do other work within ArcMap. For instance, you could zoom in, zoom out, or identify features on the map, or open tables up. You see that the script is currently working. So what we're doing here with this is we're buffering roads at 3 different distances. And you can see it's running 3 different buffers. The script's automating this one right after the other. And you can see the results on the screen here. I'll open up the table of contents so you can see that it created 3 new layers that we see were automatically added to the table of contents. So anytime you run code from the Python window, outputs automatically get put into your map for you. I'm going to turn these off. Let's talk about some basic Python syntax. This is more for the benefit of those of you that may not have a real Python experience. What we want to do is get you familiar with what the code looks like. So when we see various examples, or you can go and read sample code that's on the built into the desktop help, you'll have some idea of what that code is doing for you. One thing you'll be seeing very often of is variables. A variable contains information. It stores it. For instance, we have a variable here called first that's equal to a string called Bruce, another one called last that's equal to a text string called Harold. And you'll see that we have quotes around these text strings. This is what makes it a string. And you can use either single or double quotes like you see here. You can also take numeric data, numbers, and put them into a variable and store it. So the idea of a variable is we can use these variables all throughout the code over and over again, but we only have to define them once. So you see the number, this integer called 50. Notice it doesn't have quotes around it because it's a number. Another kind of a variable we might create is one that contains a list. And you see a couple examples of a list on the screen here. A list can contain any number of different objects inside of it. It's just a container that stores objects. You see it has brackets around it, so all lists will have these brackets. And each item in the list will be separated with a comma. So in this example, we have a list of feature classes, water, land, and buildings that are text strings. We also can have a list that contains numbers. In this case, we have 4 numbers stored in the list, separated with commas again. Actually, we can put any number of different kinds of objects into a list, but very commonly you're going to find strings and numbers in these. You can also manipulate variables. For instance, we could take 2 variables and add them together. Like you see here, we take the variable called first, the one called last, we add them together with the plus symbol, and it creates a new text string called Bruce Harold. Or in the second example here, we have an age variable called age, and we're going to add 25 to it. In this case, we're going to do some math with this. So we can manipulate variables all different types of ways. This is just 2 examples. Notice the pound signs, the green text you see on the screen. These are comments. So anytime you see this in a Python code, they're just comments. They don't actually get executed with the code. They're just there to describe it. So it's very common to see these. Another type of data that we work with in Python is called a statement. One in particular that you'll see very often is called an import statement. What an import does is it's going to import a module into your code. Python's a modular language. It's made up of many different modules, and you can load in the various modules that you need to make your script work the way you want. So you'll see there's all different kinds. We have math modules and string modules for text strings and so on. One of the modules we're particularly interested in is the arcpy module. This module is the one that gives us access to all the geoprocessing functions. So ESRI created the arcpy module, and Python can then use that to work with the ArcGIS geoprocessing functions and the properties that are within that. This is replacing the ArcGIS scripting module we had in previous versions. So this is the newer way to work. Also within this module, I think a lot of you will find interesting, is we now have a mapping module as part of the ArcPy. The mapping module is going to give you access to map documents. and layers within the map documents. This is something we've been wanting for quite a while. We can actually do this at version 10. We also have access to the 3D module. We have a spatial analyst module as well. So version 10 is very much expanding the use of these modules from the GIS or the Esri perspective. It's going to give you a lot more enhancements and ability and versatility when you write your code. Another statement we see fairly often in code is called the print statement. This is where you print something out to the end user so they can see it. You can give messages back to users, and I like to use them to debug code. Sometimes they're good at printing out the value that's stored inside of a variable we just talked about. You have another statement that's also very common to use in code. Probably most scripts I write would contain an if statement. If statements will just test to see if a condition is true or false. So if the condition is true, then it will run all the code indented under the if statement. In Python, you have to indent the code in order to make it part of the if statement. So quite simply, you can put any code you want between the if and the colon, as long as it returns a true or a false. That's all it really wants. And if, for instance, it returns a false, then it goes to the else statement that you see, and it runs all the code indented under the else. So again, Python needs you to indent the code for if statements and for loops and so on that we'll be looking at a little later in the session here. So you can go a for loop. A for loop's another kind of statement that's very common. Most scripts will probably contain one of these. And quite simply, a for loop is just a looping construction that will loop through a list. So you can get a list of items in it like we just talked about. The for loop will then go and visit that list one item at a time and do something with that. In this example, we've got a list of feature classes, and we're going to go through and print the name of each feature class out. We're going to look at the for loop a little bit more detail on the next slide here. This slide is showing an example of everything we've been talking about so far. We just put it all together into a fairly simple script here. This script is simply going to take a roads feature class and buffer it at 3 different distances. So we see the comments within the code. You also see the import. We're importing in the arcpy module. We're also setting up an environment, the current workspace environment setting. We're defining that. And we're creating a variable that stores our roads feature class. And then we see a list being created here. So the list contains 3 distances in it, 100 meters, 200, and 400. This is, then we have the for loop that's going to loop through that list. So essentially what's going to happen here is the for loop is going to go to the list, get the first distance out of that, insert it into the for loop. It's going to put it into a variable called dist, which is then going to use that to create the output name for the buffer, and then also to supply the buffer distance. So this for loop is going to take the 100 meters and output a new feature class called roads 100. The second time through the loop, it gets the second item in the list, the 200 meters, creates a feature class for it, and the third time, it gets the 400-meter distance out of the list, buffers it, and then when it reaches the end of the list, it breaks out of the for loop automatically, continues on with the remainder of your code. Let's go back to arcmap. I'll show you an example of how we can use Python in a couple of different ways just to show you how it can be used within arcmap. The first thing I'm going to do in this demonstration is I'm going to open up the Python window once again, and I'm going to clear out the code that's already there, and I'm going to type in some code. So I'm not going to load a script this time. I'm actually going to type in a code. What I'm going to do is I'm going to buffer, or actually I'm going to clip the roads out based on a city limit polygon. So to do this, I'm going to type in arcpy, that's the module we just discussed, type in clip, and you'll notice that code completes it for me. I just hit the tab key. So I'm going to run the clipping tool that's in the toolbox. Because of our encoding software, I am, instead of picking this out of a list, I'm going to actually type it in. It works better with this being encoded. So we're going to clip the roads feature class using the Mineral Springs city limit boundary. And finally, for the third parameter, I'm going to enter in the output feature class, which is going to be called roads clip. And then I'll end it with a ending parenthesis. I'm going to run this code. And as it's running, again, it's running in the background. It's going to clip the roads out. You see the tool working right now. And when it's finished, we should then have in the table of contents, we'll have a roads clip feature class that you see here that was created and automatically added. Again, anytime you run code from the Python window, it automatically puts the results into the map for you. I'll show you one other benefit of using the Python window. If you want to rerun the code you just typed in, you can hit the up arrow key. It brings the code back. You can make changes to it. You can run it again. So you can keep backing up to various code that you had typed in. So the Python window is very good at testing code for typing in snippets of code or seeing how it works. Also, again, you can execute any tool in the toolbox through this ArcPython, this window. I'm going to move on to the table that we see on the screen. This is the table of the schools feature class. And in that, we have a type column that tells us what kind of school it is, elementary, high school, or middle school. And then over here, we have the name of the school. And what I'm going to work with this time is the field calculator. So I'm going to go to the name column, open up the field calculator. And with version 10, we can now input Python code into the calculator here. So what I want to do with this is I want to change the name of the school names to upper and lowercase. Right now, all the school names are in uppercase. So I've got a script that's going to find all the elementary schools and just change their names. Then it's going to parse out all the data, all the different words that are involved in the name of a school, make it lowercase, and then make the first character and capitalize it. To do this, I'm going to load the script I've already written. It's called capitalize name. It loads the Python code into this. This is actually a Python function that we see. And basically, the code's just doing just what I said. It has an if statement in it. It has a for loop in it as well. It's going to loop through all the names. It's going to make the changes and then write the name back into the table again. So once I run this, click OK. You see it works. It took the names, and you see all the elementary schools now have lowercase and uppercase characters in their names. So it only worked on the ones we told it to. So this is exactly what we were expecting to see. I'll show you one more example. This time I'm going to the shape column. In this column, we have the shape column actually stores the geometry, so we have all the points for the school stored here. I'm going to open up the field calculator again, clear out this code, and I'm going to load in a different calculator script called Shift-X. What this script is going to do is access the XY coordinates. It's going to take the X coordinate and add 5,000 to it. So we're essentially going to shift everything over in the X direction by 5,000 feet or meters, whatever the case is. Fairly simple script. You see it doesn't take a lot of code to actually do this. I'll move this over a little bit. We're going to run the code, and you see that it shifted all the schools just like it's supposed to. I'm going to go back to this. If you're interested in field calculator scripts, which are fairly easy to write, again, just some basic knowledge of Python, and you can actually do quite a bit with these, you can go to the Help button. If you click on that, it's going to give you a lot of information about the field calculator, but probably what you'll be more interested in is the sample scripts. So there's actually sample code in this for the calculator that you can cut and paste, you can look at, and it'll give you a lot of examples of how you can use this code within the field calculator. So this is a good place to start from if you're not familiar with calculator scripts. Okay. At this time, I'm going to turn it back over to Bruce. He'll answer some of your questions.
Thanks, Mike. We've got some good questions coming in from around the globe. Firstly, John from Indooroopilly in Australia asks, which versions of Python are supported in ArcGIS 10? Well, the one we'll support, John, is the one we ship, which is Python 2.6.5. Mina from Albrightsville asks, is the Python window free from schema locks? Well, Mina, the Python window is subject to the same rules as the rest of the applications ArcMap and ArcCatalog when it comes to schema locks. That means if you're wanting to make a schema change, then you'll need an exclusive lock on the database. If you're wanting to access or read a feature class or table, you'll need a shared lock. If you're doing something like doing background geoprocessing and you're using a scripted tool to do this, then while the feature class or table is being operated on by the script tool, if it's in your user interface, it'll appear locked and you won't be able to edit it there. One thing to remember about locking if you're using personal geodatabases is that a whole of the personal geodatabase will be locked, whereas you might want to consider using a file geodatabase where only a feature class by feature class locking is implemented. Dennis from Cinderafil asks, can Python refresh any of the frame screens? Can you zoom to a feature or coordinate in arcmap using Python? And can the layer property changes via a Python script be used in a task in ArcGIS Server? Well, Dennis, yes, Python can refresh the active view, either data or layout view, for any MXD that's currently open. And in code, you can read and write the extents of any frame, so you can achieve the zooming that you want to any coordinate in ArcMap using Python, so ArcMap will refresh. And your last question, can layer property changes be scripted in a task and server? Yes, they certainly can. ArcPipe.mapping is easily used in geoprocessing tasks on server. Mike from Orange County asks, can I create a Python script to assign symbology from an attribute table conditionally based on whether a particular value is available in the attribute table? Well, Mike, what you can do with Python with regards to assigning symbology is retrieve it from another layer. So if somewhere else in your system you have layers with the symbology you're looking for, then you can do your own logical testing and indeed assign the symbology that you're looking for from another one at runtime. Sarah from Ontario asks, can I use Python in Model Builder? Yes, you can, Sarah. At 10, there's a new model-only tool called Calculate Value, which lets you use Python expressions that can include model variables, so ArcPy will know about the current model state. An example we might use is setting a branch condition based on some calculation and outputting a Boolean true or false, or perhaps evaluating another output variable based on a function of your own creation. Of course, wherever you can use Python interactively as an expression in ArcGIS, it can also be used in a process in Model Builder. Paul from Boston asks, what are the major changes to scripting of geoprocessing at ArcGIS 10? Well, Paul, the major change is that geoprocessing tools are implemented as ArcPy functions at 10. You no longer have to instantiate a GP object like you might be used to using the ArcGIS scripting module. When you come to porting scripts to ArcPy or creating new scripts in ArcPy, the biggest change that you might notice when you are using GP tool names is they're now case sensitive. So it's probably the biggest hurdle if you're a veteran scripter. You're going to much have to catch yourself a few times with handling case. Another improvement at GP scripting at 10 is that modules like spatial analyst, 3D analyst, geostats analyst, and so forth may be broadened into local scope by importing those submodules. So you don't have to do a wordy path down to the function you're looking for. Sally from Atlanta asks, why is NumPy installed with ArcPy? Well, Sally, some system script tools use NumPy for matrix calculations and array handling. So we do use it internally, but it's also very handy to have as in its own right for indeed those reasons, working with arrays and doing matrix calculations. You might, especially if you're a raster geoanalyst type of person, want to create your own functions in NumPy and send arrays over to those functions, get results turned back and use them downstream in ArcPy. Jim from Omaha asks, how do I get autocomplete working in for ArcPy in Python when we're idle? Well, all you need to do, Jim, is import ArcPy into the interactive window in either of those two IDEs, and you'll get autocomplete functionality in either open scripts in the session. Last one we have time for right now is Tim from Georgia asks, where can I find the ArcPy geoprocessing object model diagram? Well, Tim, we're not updating the OMD that you might be used to in 9.3 for the release of 10. What we'd like you to do is open up the module docs application, your Python program group. That will start a little HTML server, and you go to your browser, and you can search on ArcPy and investigate all the hierarchy of classes and functions and modules there just in your browser. So I'd like to hand back to Mike now to carry on with the presentation.
Thank you, Bruce. What we were just talking about in the last topic was basic Python syntax, how you can take that and automate geoprocessing tools in a toolbox. And that's fairly easy to do. Like I said earlier, it doesn't take a lot of expertise to make that work. What we want to move on to now in the second part of this session is talk about the advanced functions and properties. So besides the tools in the toolbox, here's an entire another category of geoprocessing functions and properties that you can access that don't normally show up in the toolbox. Now, scripts have access to this. Model Builder doesn't, for instance, but you can do it with scripts. So what we want to do, start talking about now is some of these more advanced functions that's available to you. You can find information about these in the desktop help. If you were to look up the ArcPy site package, if you did a search for that on the help, you would end up with what you see basically on the screen here. It would show you a listing of all the different categories of functions that's available to you. And then you can go to each of those categories and you'll see individual properties and functions within that that you can get help on. And then in the help, they'll have sample code for you, and they'll give you all the syntax. So this is a great way to investigate what's available to you here. These are well worth the time it takes to learn, because these will make your scripts much more versatile. You can do a lot of very powerful processing with this. We'll take a little closer look at this, these categories I was just talking about. So you have a category for cursors. You've got one that work with fields, listing. We're going to talk about some of these in the next few minutes coming up here. And again, only scripts have access to these functions. And like I said, they can really make your scripts much more versatile, and you can do a lot of very powerful things with it. Let's take a look at some of these. For instance, you have a describe function available to you. This will allow you to take some item and describe it and get information about it. For example, if you have a table, you can access the fields within that table. We can tell you how many fields it's got, which fields you have, what kind of fields that they are. We can get all kinds of information back about that table and what's inside of the table. You can also do the same thing for raster images. What kind of raster is it? Is it compressed? How many bands does it contain? What are the, what's the resolution of the raster image? So we can return information about geodatabases, workspaces. We can do the same thing for feature classes. In fact, you see the example down below here. We're going to describe a feature class, and then we're going to return the shape type. That would be, is a feature class a point, line, or is it a polygon feature class? Not only that, we're going to access one of the fields within the feature class and print out its name and the field type that it contains. So describes are very good whenever you need to make a decision with your code. So you might, for instance, if your feature class is a point feature class, you might run one set of code for that. If it turns out to be a polygon feature class, you may have a different set of code for that one. So we can use a describe function to determine what it is you're working with within your script. Another very common function that's used quite often is called a list function. This is going to return to you a list of, for instance, for feature classes or a list of tables. For instance, I can go to a geodatabase, scan through it, and get a list of all the feature classes that are in that geodatabase, or all the tables that are within it, or all the raster images that are stored in it. Or I could go to a folder, scan through the folder, and return a list of everything that's inside of it. So we put these things into a list. It's actually a standard Python list like we talked about earlier. You can manipulate that list. You can add to it, take from it. And more importantly, we can use a for loop then to loop through that list one item at a time. So you see the example that's on the screen here. We're going to get a list of feature classes. We're going to use a for loop to loop through that list. We're going to go to, and this list happens to contain shapefiles. So it's probably a list of all the shapefiles in a folder. The for loop goes through each shapefile, and then in turn will convert it into a geodatabase. And that's what you're seeing happen with the copy management tool. So that's just simply copying it over to a geodatabase. And the idea here is now we can do batch processing with this. So we can write a script that's going to process hundreds of pieces of data, information like this, and then we can just let it run on its own. Another function that you'll find very helpful is called a cursor. Now, a cursor is simply a collection of records. And a cursor is going to allow you to access a table or a feature class and access all of its records. Once we have the cursor, then we can loop through that cursor one record at a time. And not only that, but we can also read and write to the table. So this is what gives us the ability to basically edit a table, if you want to think of it like that. So we can write values to it, read values from it. We could even add new records to it or delete a record if we needed to. So cursors are very versatile. We can also access geometry through it if you wanted to. The example we see on the screen here is creating a cursor for the roads feature class. In fact, we're not getting all the roads. We're actually going to get only the roads where the road type is not equal to 4. So we can even constrain this down with query expressions to just put just the record you want inside of that cursor. Once they're in the cursor, we can use a for loop then to loop through it one record at a time, like you see in the example. In this example, we're going to loop through each road and print out the road name and the CFCC code and print those out to the user. For those that may be already experienced with Python, if you've used this before, in version 10, you're going to notice we can put the cursor into a for loop now. In prior versions, we had to use a while loop. The construct was a little bit different, the kind of code that you've written. So now this is a little bit more streamlined than it used to be. We can now work with the for loop rather than a while loop. Geometry object. This is something else you might be very interested in. Like I said earlier, we were able to manipulate geometry. There's about 3 or 4 ways we could actually do that. We saw one method already when I did the demonstration in the field calculator. But there's a couple other ways we can also deal with geometry. We can work through a cursor if we want to, like we just talked about, or in this example that you see on the screen here, we can take geometry and manipulate it. So we may write a script that's going to delete it. We can even change the shape of geometry. We can move it to different locations if we want, or if we would like, create a whole new point line or polygon and add it to a table if we'd like. In this example on the screen, we're going to create a geometry object. You see that where my cursor is here. This geometry object we put into a variable, and then we're going to go to a tool called Copy Features. This is just a standard tool you'll find in the toolbox, but what we're doing different with this is we're adding this geometry object into the output. So rather than actually copy the features into another feature class, we're actually going to copy them into the geometry object. And essentially, this is going to return to me a list of all the geometry, in this case, all the lines and all the streets that are in that will be put into this list. This is something that's fairly new at version 10 that we can do with this geometry object. So this is an alternate way of working with it. For those that have worked with geometry before, you might want to take a look at this example here. And by the way, all these examples we're looking at, these all came from the help. So if you look in the help, the desktop help, you'll find these same examples there that you can work with. Once we have the list of geometry created, we're going to use a for loop to loop through that list like we've been talking about. In this example, we're just simply going to total up the total length of all the roads in the streets feature class and then print that out. You could take a Python script and add it to the toolbox as a script tool. You'll find script tools very useful. Once you do this, the script takes on all the properties and the behavior of a normal tool. So if you know how to use tools in a toolbox, you'll automatically know how to use a script tool. There's nothing really special or different about it. In fact, that script tool can even execute executables or AMLs that you may put in there or batch files. So we can not only execute a script, but we can actually call other code and run it from the toolbox as well. Like I said, it takes on all the properties of any other tool, so that means that you're going to receive the same messages back that any tool would give your user when you run it. We have access to all the environment settings that you may take advantage of. And what I think is probably the most important here is anytime you run a script from the script tool, it will automatically add your output to your map. So if you're running this from within arcmap, it will be added to your table of contents for you. Other advantages of script tools: once you have a script tool created, you can easily share it with other users. You can email it to another user. They in turn can add that to their toolbox and place it in there, double-click it, and run it very easily. Users don't have to know anything about scripts. They don't even have to know this is a script, actually. They can just double-click and run it like any other. So you can share these. Script tools also have the ability to automatically create dialogues. You don't have to write any code necessarily for these dialogues. These are built into ArcGIS that we created for you. And I'm actually going to show you an example of this in just a few minutes. We'll see how this is actually accomplished. And new at version 10 is the ability to take any tool in a toolbox and put it into a toolbar or into a context menu. So this is something that will you no longer have to just run tools from the toolbox. You could actually close the toolbox out, put that tool into a toolbar, execute it from the toolbar like any other button that you find on that toolbar. So this is something people have been asking about for a while. You can now do it in version 10. And yes, you can take a script tool and add it to a model. So Model Builder can work with the scripts as well. And like I said, it's just another tool. So you can put basically any tool into a Model Builder and execute it from that if you'd like. I'm going to go back to ArcMap, and we're going to look at a demonstration. What I'm going to do is take a tool, a script, and turn it into a script tool. And I'm going to show you how we can execute that. So what I'm going to do, I'm going to zoom in to a particular area here on the map. This is the boundary between two cities. And you'll notice the boundary between the two cities has been badly digitized. It's, they're not really coincident. You'll see a lot of digitizing errors along the boundary. There's now a new toolbox added to version 10 that does editing for you. So there's an editor toolbox that's now been added. And I'm going to use one of the scripts to access a snapping tool that's in that toolbox. The snapping tool is going to, in turn, snap the vertices between these two boundaries together. So in essence, it's going to do some editing for me automatically. So this is actually a nice new feature that's been added to 10. First, though, I need to make a script tool for this. I'm going to go to our catalog to do that. Notice we can now run our catalog from ArcMap. I'm going to go into my toolboxes, and I have to create a toolbox in order to add a script to it. So I'm going to create my own custom toolbox. And in the toolbox, I'm going to now right-click it and add a script. So the script already exists. Actually, I think what I want to do right now is show you the script. This might make more sense if you actually see what the script looks like. So I'm going to go to the Python window here, and then under Python Win, the editor. This is a script I'm just about to add to ArcMap. So if you want to see what's in the script, you'll notice that we're importing the ArcPy module like we just talked about earlier. And what I really want to point out to you is this. These two lines of code, these are Python arguments. And what that means is whoever runs the script is going to have to supply these two arguments to the script. It's going to expect that that data is going to be given to it. Since I'm running the snapping tool, the snap tool needs to know what layer am I going to snap to, and then what the snapping distance is that I'm going to be working with. So I'm going to have these two arguments supply that information to the tool. In other words, the user of this tool is going to be able to supply that. So they can run this tool in any number of different feature classes using different snap distances if they would like. So that we know what it looks like. The other reason I'm using a script for this tool is this. Since this is an editing tool, I'm going to have it automatically make a backup of my data before it executes the tool. So in this case, if we always run this tool from a script tool, from a script like this, we're always ensured that the backup will always get created first. That way we know that even if something goes wrong, we can rely on the backup to replace it. I'm going to return to ArcMap. In ArcMap, remember, I'm adding my tool to this toolbox now. So I'm going through this wizard. First thing it wants to know when I add the tool is, what do you want to call it? So I'm going to call my tool Snap. Same thing for the label. I'll just give it the same name. We'll go to the next. Then it wants to know which script do you want to add to this particular tool I'm creating. And that's going to be that snapping tool script that I just looked at. So we're going to open that tool and we're going to add that snapping Python script to this. And the next dialog, this is the important one. This is where we supply those two arguments. So remember, the script has two arguments in it. We need to create a dialog box for the user to fill out. So this form that you see in front of you is going to do that for you. So I'm going to prompt the user to select a layer. This is going to be the snapping layer. Then I need to tell it what's the data type. In other words, what kind of data am I going to ask the user to supply? And you see there's all kinds of data I can ask the user for here. The one we're interested in is called the feature layer. Next, the second argument that I need to prompt the user for is the snapping distance. So I will ask the user to enter a snap distance. And the data type that works best for a snap distance like this would be called a linear unit. So I find a linear unit type. This is going to prompt the user for a number and a unit of measure. such as meters or centimeters or feet or inches, whatever the interest is. You'll see that there's a number of properties down here I can also set. I'm just going to default all those. I'm going to finish. If I go back to our catalog, you will see it has now created a snapping tool, added it to my toolbox. Again, it looks and acts just like any other tool does. If I were to double click this tool, we'll run the tool. When I run the tool, it's asking me for those two arguments. So it's going to ask me to select a layer. I'm going to pick out the mineral springs layer. Then it wants the snap distance. I'm going to type in 30. And I think I will make mine just 30 meters. It's kind of large for a snapping distance, but you'll see it should work for us. I'm now going to execute this by clicking OK. It's going to run the script. And you see, after the script runs, you see now that it cleaned up the borders. It snapped all the vertices together for me. It did that automatically. So for those of you that have to do this kind of work, or you are maybe manually digitizing this, you might actually have a script that will be able to go out and clean up a lot of the boundaries and lines and points that aren't contiguous like you'd like them to be. So this is going to be a real time saver. Remember, you can do this at version 10 with that new snap tool. There's other editing tools in that toolbox as well. There's one that will extend lines and so on for you. So snapping is not the only one available. I'm now going to turn it back over to Bruce.
Thanks, Mike. Another Mike from Albany asks, will you be able to access and or update metadata with ArcPy? Yes, you can, Mike. 10, there's a rich set of metadata geoprocessing tools that let you import, export, and validate, and so forth, your metadata with ArcPy. Loanne from Livermore asks, can you set Python to run specific code automatically once a month? Yes, you use your operating system to do this, Loanne. So in the Windows environment, you'd use Windows Scheduler. In the Unix environment, you'd use cron. And then the operating system will call Python, and within that, of course, you can call ArcPy functions anytime you want. Nenad from Wellington asks, hello, will some existing Python scripts created in 9.3.1 that are running as scheduled tasks need to be modified for ArcGIS 10, specifically with regard to modules, object models, and case sensitivity? Short answer is, Nenad, no. They'll continue to work just as they do currently. You won't have to do any porting of your existing Python code. Vincent from Indooroopilly in Australia says, can you use Python without ArcGIS running? Yes, you can, Vincent. You don't need to have any arcmap or arccatalog session open for a Python script to import ArcPy and execute any of its functions. Michael from Pontotoc in Tennessee asks, after typing several commands into the embedded Python window, can the code be exported from the window to a Python script, or will you have to copy and paste? You can do either, Michael. You can, with a context menu on a right click, you can export the history of the Python window to a PY or TXT file on disk, or you can, if you want, select and copy paste all of it independently. Marisol from San Francisco asks, is the Python window available for ArcGIS 10 only, or also for 9? And if we write Python code for 9, we'll be able to read it in version 10. The Python window is only in ArcGIS 10, Marisol. If you wrote Python code for Arc9, yes, you can read it in version 10. You can import it into the Python window or continue using it in existing scripts. Dinesh from Milton Keynes in the UK asks, can Python code written in idle be imported into ArcGIS 10 desktop? Yes, very simple, Dinesh. Just save your development work out of your window on idle to a PY file, and you can import that into the Python window interactively in desktop, or use it straight away in the script tool. Mark from Corvallis asks, can you still use ArcGIS scripting? Yes, Mark, ArcPy is built using ArcGIS scripting, and ArcGIS scripting is still fully available. You can continue coding the way you used to with ArcGIS scripting if you wish, or you can port your workflows to ArcPy. Claudia from Sioux Falls asks, in the Python field calculator, does it include the power function? Yes, it does, Claudia. In fact, all of the math module is imported into the field calculator now, and the power function is certainly there. Tom from Columbia Falls asks, why is Esri moving away from VB? Will VB be in future releases, or is everything going to Python? Well, with respect to VBA, Tom, we're moving away from VBA after ArcGIS 10 because Microsoft are removing support for it, so we can't support it ourselves in the absence of their support. For VB script that's still supported in the Windows applications, it remains our way to do things like label expressions, and indeed you can use it in the field calculator currently. Last one I have time for this session. Claudia from Sioux Falls asks, does the Python window replace the command line window you find in previous versions of ArcGIS? Yes, you're exactly right there, Claudia. The Python window does replace the command line window from ArcGIS 9X, and at 10, what will be there is the Python window alone. So with that, I'll hand back to Mike.
Thank you, Bruce. We're going to continue talking about some of the advanced functions and properties we've been discussing. And what we want to focus on right now is the new mapping module that's been added to version 10. I think a lot of you are going to find this very interesting. The mapping module is what's going to give you access to a map document. And you can have quite a lot of access to it. So that means we can access data frames, layers, we can have access to layouts, actually. So you can do quite a bit with this new module that's been added. There's a lot of documentation on this, a lot of sample scripts that you can look at that would show you examples of how this is being used. Now, I want you to understand that this is not going to allow you to create a map document, but you can manipulate existing map documents. So you can open those documents up, retrieve all the contents that are within it, look at it. You can even query and find certain things within it. And you can have the ability now to print a map. You can export a map out into various graphics formats. You can even save it as a copy, or you can just save over an existing map document if you'd like to. So you can make changes to it, save it out, just very much like you would do if you were to manually open it and edit it and work on your map document. You can use scripts then to automate your workflows and involve map documents. This is something you could not do in prior versions. And one of the bullets here that you see, it's called update and repair data source. I think a lot of you will find this very interesting. This is going to allow you to go into a map document and repair any broken links or any sources that are broken in your layers. So you see the familiar red exclamation point or mark that you have beside each of your layers that are broken. You're now going to be able to fix that through code. You can do this in a batch mode if you'd like. So this is going to be something I think a lot of users will find very, very useful. Not only that, you could use it to create a report. You can open up a document, scan through it, look and see what's inside of the document, write it out to a text file, or make some type of a report out of it. You can also use Python scripts to automate the new PDF map books that are in version 10 now. So if you want to automate that kind of a workflow, you can use that with the new map books that you're going to see in version 10. Looking at the map document, you're going to have access to data frames and layers within that map document. So we're going to be able to change properties. We're going to be able to add data frames, remove data frames. Same thing with layers. We can add layers, we can remove layers. Not only that, we're also going to have access to the properties. So we can manipulate properties of a data frame like you see here. So for instance, we could change, we might want to change the rotation of a data frame. Maybe we want to change the extent of it. We could apply a different coordinate system to it if we wanted to. And if you look at the example code down below here, that's exactly what it's doing. The code you're seeing is going to find a map document called project.mxd. It's going to go into that map document and make a list of all the data frames within it. So here's the list again in the for loop that we've been talking about. And we're going to loop through that list of data frames, one data frame at a time. We're going to set each one to a 0-degree rotation, set the scale at 24,000, and then export it out as a TIFF image. So we're going to do this again in a batch mode for each data frame that's in that map document. You can do the same thing for layouts, actually. We'll switch over to layers. We have access to most of the layer properties. So if you're familiar with layer properties, you'll recognize what's in this list. For instance, we can change the transparency settings. We can turn a layer on and off. We can turn its labels on and off. We can change the source data again. That's one you'll be particularly interested in. And if you look at the sample code below here, you'll see an example of opening up a layer file. Now notice, in this case, we're actually opening a layer file out on your hard drive. So the layers don't have to be in a map document. We can access layer files independently if you'd like. We're going to take the layer file. We're going to go into it. We're going to change, we're going to set a name for it to call it highways instead of streets. We're going to turn its labels on, and then we're going to save a copy of this out. So in essence, we just took a layer, made some changes to it, and saved it out as a different layer. So now we have one layer that has streets without labels and another layer that has streets with labels. And we did this all through code. So it's just an example of how you can manipulate layers within a map document or within a layer file and work with it. I'm going to go back to arcmap. I'm going to show you an example, a couple of examples actually, of how we can manipulate layers and work with these. So I'm going to go open up my table of contents. You're going to see we have a layer in here called hydrants. These are fire hydrants. And what I'm going to do is I'm going to open up the Python window again, clear out the old code, and what I'm going to do, I'm going to load a script in once more. This script is going to change a layer. So I'm going to open the script, and what I want to show you is a couple lines of code in here. I'm going to go up to the top of the script, and notice here when we find this is the line of code that's going to find a map document. Notice how we're going to set the map document to current. This means that this script will use whatever the current map document it is that I have running. So if I run this code from the Python window or as a script tool, like we just talked about, it will automatically find the current map document and go into that and do something with it. What I'm going to do with this map document is I'm going to find a layer called hydrants. I'm going to take that layer once it's located, and I'm going to define a definition query for it. I'm going to change its name to dresser hydrants. I'm going to make it visible, turn it on, and we're going to turn the labels on for it. So let's execute this. We're going to press the Enter key. It's already done. Works very quickly. We're going to go to the table of contents, and we'll see what the results are. I'm going to refresh this. You'll notice the layer has now been changed to dresser hydrants. And if I turn it on and off here, you'll see that it also turned the labels on. So the labels are actually part of this now. We can turn that on. And if I were to go to the properties, the layer properties, you will now notice that the definition query has been defined just like I told it to do in the script. So the script actually manipulated all these properties for me. Again, you can do this with any layers that's within this map document. And we can also rearrange layers, turn layers on and off. You can remove a layer, add a layer to this map if we wanted to. There's actually quite a lot you can do with this. This is just a simple example of how you can manipulate this. I'm going to show you one more example. In this one, I'm going to open up a different map document. In this map document I'm opening, it's going to have 4 layers that are broken. In other words, the source, it cannot find the source information for those layers. This is a fairly typical problem. Happens anytime you change the name of your data to source data or you move it from one location to another one. A lot of you are probably well aware of when you do that, your map documents can no longer find the source data. Let me try this again. Open it up. Okay, here's what I'm talking about. You see in this this new map document, there are 4 layers with the all too familiar red exclamation mark next to them, meaning that these are broken. You see that the layers don't show up on the map. What I'm going to do is I'm going to run a script from Python 1 that's going to fix this. So first I'm going to set my map document to a blank map. I'm going to do this because I'm actually going to save over that map document. I can't save it as long as it's open in arcmap. I'm going to switch over to Python Win. We'll close the old code out. This is the script I'm looking at right here. It's called the fix broken. Essentially, you see it's a very simple script. Manipulating map documents like this doesn't have to be anything really difficult. Again, you can find this kind of code in the desktop help under this, and there's samples of this. Notice what we're doing. We're going to import the arcpy module. We're then going to find the broken map MXD, so we're locating the map document. And this is what's interesting here. I'm going to go into that map document and make a list of all the broken layers. So all the layers that have broken data sources will be put into my list. And then I'm going to go and change the source name of those layers. So it's only going to work on the broken layers. It leaves the other layers alone. We're going to change the name of it and make them correct. And what's really interesting with this is notice that I'm now going to save this map document. So once I made the changes to it, I'll turn around and I save it. So it's run the script. I'm going to run it from Python Win. Works very quickly, so it's already finished. We're going to go back to ArcMap. We will now open up that same map document again, and this time we should see 4 layers that have been fixed. So we should see the layers draw on the screen. And now you see the layers. We'll go to the table of contents, see everything's fixed now. So all's right with this map document. This is much better and much faster than we used to work with when you had to manually edit this and work with it. This is going to be very useful for you if you want to batch process large numbers of map documents. You can do that. You can go in there and fix it anytime your data moves or changes. This should save a lot of users a lot of time. I'm going to turn this back over to Bruce. He's going to...
Thanks, Mike. Eagle and Parnell ask, are you planning to allow Python to calculate labels or use Python for label expressions? Yes, it is planned, although it won't be in the release of ArcGIS 10. You can look forward to using Python and label expressions in a future release. Georgita from Boulder asks, can we create an MSD using Python and publish the MSD as a service in the same script? For other people not aware, an MSD is a map service document which is optimized for rendering of the map and used in ArcGIS Server. Now, Georgita, because we're expecting an analysis step during the authoring of the MSD, we don't currently support the writing of MSDs with arcpy.mapping. So because we're expecting another authoring step between the authoring of the map and the publishing the MSD, we're not supporting writing MSDs and publishing them in the same script. Aaron from Denver asks, is there a Python script for snapping one layer to another rather than within itself? Well, Aaron, yes, the snap editing tool at ArcGIS 10 supports what's called a snapping environment. You can use any number of other feature classes as snapping targets and in different ways, in addition to the feature class being edited. Georgita from Boulder again asks, can you share a tool based on a Python script but with a compiled version of the script? Georgita, we're not supporting compiled versions of scripts for script tools because there's really not much point. Compiled Python runs at the same speed as ordinary PY files, but I think what you're getting at there is, can you embed a script and somehow encrypt it? Well, we password or let you password protect scripts. So there's one way you can share a script, but not let it be fully exposed. Mirko from, I beg your pardon, Paddy from Corvallis asks, can you run a cursor and model builder through a script? Well, I think a couple of options there for you, Patty. At ArcGIS 10, we have a model process called an iterator, which will let you effectively run a cursor through a feature class or sets of values or what have you. So that's one way of looking at that. Another way is, yes, you can outright run a cursor and model builder by using the calculate value model tool in model builder, which just runs any Python code that you put in there. Russell from Edna asks, can the script add output to a new map or data set instead of the current? Yes, Russell, you can write out any layer in memory and add it to any other map document that you create on the fly or have on disk, so you can add output to a new map or data set instead of the current one. Claudia from Sioux Falls asks, is it possible to automatically add symbologies to several outputs from a Python script? Yes, Claudia, provided you can retrieve the symbologies that you need from other existing layers or map documents, then you can automate the application of them to new outputs from scripts. Time for one more. Kamal from Toronto asks, can Python be used to create a list of files used and their locations with an MXD file? Yes, Kamal, it's one of the primary use cases we see for the ArcPy mapping module. You can certainly generate a report of the data sources used and where they are from a script. So with that, I'll hand back to Mike to wrap up.
Thank you, Bruce. Before we go, we'd like to point you to a few resources that you see on the slide on the screen. If you want to know more about geoprocessing tools, there's a online web training class you can take that will explain a lot of that to you. If you're more interested in learning Python and how we can work with some of the advanced functions that we talked about, we have an instructor-led training class, the Introduction to Geoprocessing Scripts using Python, that you can take. This will go into all the details about working with scripts. If you want other resources to learn Python, there are a number of books available to you online or in bookstores that are fairly good, that can give you information about all the basics of working with Python. There's also websites that's devoted to Python, like python.org, for instance, is a good one that you can rely on. We have other seminars like this one in the weeks and months ahead that you can also watch to learn more about ArcGIS 10, so there'll be more information forthcoming. I hope you found this seminar helpful. I hope this has given you some ideas about how you can use Python and integrate it with ArcGIS and make your workflows easier and make your work go a little bit faster. Your comments help us to improve our seminars, so please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you enjoyed today's seminar. On behalf of Esri, I'd like to thank all of you for attending.